So here are some more questions to practice regarding the increasing, decreasing intervals, critical numbers, inflection point, intervals of concavity, and relative extrema. So here the question says that for all x, the first derivative is given. They are not giving you the function, they are giving you the first derivative, which is equals to x minus 2 whole to the power 4, x minus 1 whole cube. They are asking you that find whether it has the relative minimum at 1, relative maximum at 1, relative minimum at 1 and maximum at 2, or nor a relative minimum or a maximum, or at relative minima at 1 and 2 both. So how can we find it out? So we know that the first derivative should be equals to 0. Now one by one, find out, solve the factors. So x minus 2 whole to the power 4 equals to 0. Make it x minus 1 whole to the power 3 equals to 0. Now solve for x. So you can write x minus 2 equals to 0 and x minus 1 equals to 0. Now, maybe you want to ask me that how you did it. Of course, if you took the fourth root of 0, okay, so of course the fourth root of 0 or 100th root of 0 is 0. That's why I didn't solve these steps and I wrote it directly. Okay, after that you have x equals to 2 and x equals to 1, and they both are your critical numbers. But in order to find the relative minimum and maximum, it is necessary to perform the first derivative test. So in order to perform the first derivative test, you just sketch the number line and write all the critical points on the number line from negative infinity till infinity. Now choose a number between negative infinity till 1 and put it in the first derivative. So for example, if I choose here 0, so 0, this one will give me a positive number and this one will give me a negative number. So I will have a negative number here. Okay, so if I from here 1 to 2, if I choose, for example, 1.5, so let's better to solve it properly rather than just making a mistake and then in the end we will come up with a big mistake. So let's try to choose the numbers. Okay, so first we chose 0 and we got a negative number, and when we choose negative 1.5, sorry, positive 1.5, so we choose positive 1.5, we get a positive number, and on choosing between 2 till infinity, again we will get a positive number. Okay, so negative means a slope is decreasing, and positive means you have a positive graph is increasing, and again from 2 till infinity the graph is increasing. So let's see, you have at 1 you have a relative minimum and you don't have any relative maximum. Okay, so our answer is relative minimum at x equals to 1 is absolutely. Question is x to the power 3, x cube minus 3x squared plus 3x plus 7. So I am writing my question, x cube minus 3x squared plus 3x plus 7. Which of the statement is true? And in this statement, they are also asking about some relative extrema and increasing, decreasing points, and also that's it. Okay, so the first thing is it is very important to take the derivative of the function. So you will have 3x squared minus 6x plus 3. Set the equation equals to 0. You will get 3x squared minus 6x plus 3 equals to 0. And from the question, you can say that there is a 3 as a, you can take 3 as a common. So you will get x squared minus 2x plus 1 equals to 0. So divide both sides by the 3 and you will get only x squared minus 2x plus 1 equals to 0. Now if you factor this, you will get x equals to 1 and x equals to 1. Because the factors are x minus 1 and x minus 1, because minus 1 and minus 1 gives you minus 2 and minus 1 times minus 1 gives you 1, positive 1. So your critical numbers are x minus 1 equals to 0, which gives you x equals to 1 2 times. Okay, so this is your critical number. Now, on the critical number, either you will have a relative minimum or maximum. This can be found by just choosing the number and putting in the equation. So, first of all, choose any number. Choose any number between negative infinity and 1 and write it in the function. So, for example, if I choose 0, so I will get a positive number. And between 1 and infinity also I will get a positive number. It means the whole time the graph is increasing actually. Okay, so overall the graph is increasing throughout the period. Okay, but I have a decreasing and then the increasing point. Okay, so after that one, what I will do, I write here my increasing points from negative infinity till 1 and my decreasing points from 1 till infinity. I have no relative minimum and maximum. Just I'm writing to make sure that what we will find, our data, we can just sort out from there. Okay, one more thing, they are asking us that about some inflection point. So of course, for inflection point, let's check, do I have an inflection point or no? So if I take the second derivative, I will get 6x minus 6. So on solving or setting the equation equals to 0, I will get x equals to 1. So on the 1 is also my inflection point. Okay, so whether it is an inflection point or not, how can I find it out? Let's see here. If I have here 1, negative infinity till infinity. Now put a negative number or between negative infinity till 1 in the second derivative. So for example, if I choose 0 and put it in the second derivative, I will get a negative number, negative answer, negative 6. If I choose 2 from here, so, and I put in the second derivative, I will get a positive sign. So, negative means concave down and positive means concave up. So, here I can say that 1 is my actually inflection point because in the graph I have all my real numbers. The thing is that why I am getting a wrong answer over here because x minus 1, so that is all correct. But let me check with my factorization. Yes, it is all correct. So I have an inflection point. So let's try what we are going to have. What we are going to have. So here plus and 3 plus 3 6 minus 6 0 3 times 2. Okay, all correct. Okay, so now f has a relative extrema, so that is not correct, and no inflection point. This is wrong. F is everywhere increasing and does not change concavity is also wrong because F is yes everywhere increasing but it has the concavity. F has no relative extrema but has an inflection point at x equals to 1. This is correct. F has relative maximum and an inflection point. No, it doesn't have any extrema, so no relative minimum, no relative maximum, only it has an inflection point. That is true. So my third option is true.